Hello everyone. In our last class, we discussed about the dispersion of light. Right? Here we are going to discuss one more concept. Right? Then have you ever observed a sky appears blue in color? Sometimes it appears in white in color. Sunrises and sunset times it appears in red in color. What is the phenomenon behind it to appears like different eyes, like blue, like white, like red in color? Right? To know that, we have to learn one more important factor, one more important phenomenon. Right? Before that, simple one. Then when you open the tap, okay, if you open the tap, then water falls on the surface, okay, on the polished stone. Then when you open the tap, the water falls on it. The water falls on the surface. Have you noticed that when water fall on the stone, the water droplets are sprinkles in all the directions? Isn't it? Got it? When you open the tap, the water is falling from the tap. When the water falls on the stone, the water sprinkles in all the directions. We are observing daily, right? Got it? Like same, what happened if light falls on the atoms or on molecules? Right? Get it? When a light fall on an atom or on a molecule, then the light also sprinkle in all the directions like water. Got it? When water fall on the stone, the water drops. When it is falling, the water drops or sprinkles in all directions. Like that, when light fall on the molecule or an atom, then the light also spreads in all directions. That concept is called as scattering of light. Got it? Then, so now we are going to discuss about the scattering of light. Okay. What is our topic? Scattering of light. We know that our earth consists of atmosphere. Around the earth we have atmosphere. That atmosphere consists of many gases like hydrogen, nitrogen, water droplets, or different molecules are present in air. Right? Then for example, this is the atom. You feel it is an atom. When white light fall on it, when the white light fall on it, then it absorbs the light which fall on the atom or a molecule. It can absorb. The light is absorbed and it responds for the light by vibration. When the light fall on it, when the light is absorbed by the atom, it can respond. That means it vibrates. It vibrates and it re-emits the light in all directions with and different intensities. This phenomenon is called as scattering of light. This phenomenon is called as scattering of light. What is scattering of light? When light fall on the atom, it absorbs and re-emits the light in different directions with the different frequencies, okay, and with the different intensities. So with the different intensities is called as scattering of light. Got it? Right? Then here Sir, this light is called as incident light. This is incident light. Okay. Then this atom is act as a scattering center. This is act as a scattering center. Atom is act as a scattering center. This re-emitted light is called as scattered light. Got it? The re-emitted light is called the scattered light. Got it? Right. And here the angle between, then incident ray is traveling in this direction, right? The path of a incident ray in this direction. The angle between the incident light and this scattered light, here it is scattered in this direction, right? Here this angle is called as angle of scattering. Got it? The angle between incident light and scattered light is called as angle of scattering. Okay, and here we have noticed that the angle of scattering angle is equal to 90 degrees. The intensity of light is more. When the scattering angle is 90 degrees. That's why when we see the sky vertically upward, the sky appears in blue in color, very brighter. Okay, clear blue color we can see. Then if we see the sky with a certain angle, that intensity of light can decreases. The intensity of color is decreases. Okay, when maximum intensity, when the angle of scattering is 90 degrees. Got it? This is about scattering. Scattering of light means re-emission of light. Re-emission of absorbed light with different intensities is called as scattering of light. Why intensity is changing, sir? While changing the angle of scattering is changes, then intensity of light is also changes, right? Then in which atom or in which molecule the scattering takes place, that atom is called as scattering center. Then the re-emitted light is called as scattered light. Okay, got it? Right. Then here one more important thing you have to notice it. The scattering of light depends on wavelength of light. Okay, the wavelength of light should comparable with the size of atom. Okay, right. The wavelength of light should be comparable with the size of the atom, then only the scattering takes place. If a size of the atom is compared with the wavelength of a given light, then it's scattered. Right? Got it? Then wavelength of a light is comparable with the size of the atom. Okay, got it? This is an important thing. Okay, right? Got it? That means lower than atoms, or most of the atoms are scattered. The most of the atoms are responsible for a higher frequency. If lower the wavelength, higher the frequency. Right? Got it? Then this is about scattering. Here you have to notice this one thing you have to remember it. Then the scattering takes place when the wavelength of a given light is comparable with the size of the atom. Right. This is about the scattering of light. Very simple phenomenon or not? Okay. Right. Here the light in the scattering, the light is re-emitted in all the directions, okay, with different intensities, right? When the light is fall on the atom, it responds. How it is response? When light is falls, it shows vibrates. Due to this vibration, that causes the re-emission of light. Due to the vibration, it causes the re-emission of light. Okay, got it. Then now we are going to discuss some of the important applications of scattering of light. It is an important, applications are very important. Based on these applications, you may get one question in annual examination. Okay, right. My first application, then why sky is appearing? Why sky is appearing in blue in color, blue in color. Right, this is the question. Here we know that atmosphere consists of many gases such as oxygen and nitrogen, right? It consists of oxygen molecules and nitrogen molecules, right? These oxygen molecules, the size is comparable with the wavelength of blue light. The wavelength of blue light is comparable with this oxygen molecule. Okay, due to that oxygen or nitrogen almost all are similar in size. So this blue light wavelength is comparable with the size of the oxygen atom or nitrogen molecule. Then it re-emits the light in all directions. Okay, then we know that in atmosphere oxygen nitrogen gas are more percentage. Due to that reason, much scattering takes place by the by the blue color light comparing with the other colors. Due to that reason, the sky appears in blue in color. Got it? Very simple. Why sky is appears in blue in color means then the wavelength of the blue color is comparable with the size of the oxygen nitrogen molecules. So that's why the much scattering takes place in the oxygen and nitrogen molecules. So that's why it appears in blue in color, right? To appears brighter, if we see from here, then sky appears very brighter. Why? Because your angle is the right angle, that means 90 degrees. If we see from here, it appears little bit less brighter. Then why? Because the angle formed is less than 90 degrees. Okay, got it? Then that's why here it appears then a little bit less brighter. Okay, got it? This is the reason why sky appears in blue. Okay, right. Always, sir, always the sky appears in blue in color. We know that in noon timings, in summer noon times, if you observe the sky, it appears in white in color. It appears white in color. Sir, why? Sir, why? Then here in a noon timings, in summer noon timings, the much evaporation takes place. What takes place? Evaporation takes place. Due to that reason, more amount of water droplets are present. Water droplets are present. Okay, then size of the water droplet is much greater than the remaining molecules like oxygen or nitrogen. Due to that reason, light, the white light is all wavelengths also scattered. all wavelengths, that means all total light can be scattered with this water molecule. Then you feel this is water molecule, then it is re-emits in all directions. Then in all directions, all colors at a time will comes out, right? That means all colors are coming in the parallel in the same speed. No, then again we feel that the sky is white in color. Okay, only one reason why in summer noon timings, the sky is appearing in white color means due to the more number of water molecules are present in atmosphere, then the size of the water molecule is comparable with the white light. Okay, with the white light. So that's why the white light is scattered with the water molecule and it re-emits light, white light. So that's why it is appearing white. Same it can be applicable for clouds. Why clouds are appearing in white? Why clouds are appearing in white? Then same phenomenon we can able to takes place for it. Okay, right. Same, it has a clouds consist of water and dust particles. No, their size is comparable with the white light. Due to that reason it appears in white. Okay, why water is appears in blue in color in oceans, blue in color or greenish blue? That is also the same phenomenon. Then the light is refracted, then scattered light is refracted into the water. So that's why it is appear blue in color in oceans. Why? Because its sizes that particles or size of the particles are comparable to the blue color light. That's why sea water is appears in blue or bluish green. Okay, right. Then next, here one more thing. Sir, why sunrises time and sunset times then sky is appears or red in color, Sir, why it is? Then you can see it. Then this is the earth. Okay, our earth consists of the atmosphere. Okay, this is called atmosphere. Here it is, right? And you have to notice one thing. Sun rises time, for example, this sun rises time and sunset timings and sun here at noon timings. Okay, comparing the distance between moon and the distance between sun and the earth in case of sunrises and sunset timings are a greater distance when we compare it with the distance between sun and earth in the noon timings. Got it? That means here the distance between sun and earth is greater in the sunrises time and sunset time. No, so the light should travel much distance in the case of sunrises and sunset time comparing with noon timings. Right, got it? Then that's why when white light is enters here, right, into the atmosphere, then here it consists of many molecules. Then that molecules are comparable size in the blue color and comparable size in violet. Some of the molecules are comparable size of blue, some of the molecules are comparable size of a violet, such as in different colors, different sizes. Due to that reason the scattering takes place by the blue color and violet color and remaining all colors when light is enter into the atmosphere, and the light can vanish out. Okay, the all colors are vanishing. Here the blue color is vanished out, then it emitted this, the remaining all colors, right? But red colors wavelength is greater. The red colors wavelength is greater. So that's why the less amount of scattering takes place. That's why then it reaches our earth. Right? Remaining all colors are vanished out before reaching our earth. Before reaching our eye, the remaining all colors are vanished out in the sunrises time and sunset time. only red color is reaching to our earth, no, our eye, no. So that's why we feel that then atmosphere, that sky is appears in red in color. Okay, why? Because then one see, for example, this is the size of the molecule in the atmosphere, right? Here white light is comes, okay, and the size is comparable, sorry, blue color light is came, then it is comparable to it, and then red colors has higher wavelength, so like that it escaped. Then have you noticed the red color, then here the molecule, and it the size of the molecule is less than the wavelength of red color. So that's why the wavelength is greater than the size of the molecules, the scattering will not take place, so it moves, right? But here blue color's wavelength is comparable to this, then scattering takes place here, then they re-emitted here only. The total blue color is scattered before reaching the atmosphere, but here our earth no, then only the red color is reaches here. So that's why in sunrises time and sunset times the sky is appears in reddish in color. In which color? Reddish in color. Okay, this is the reason. Got it? Right. So okay, and here same concept, then that's why here you came to know that the red color is travel much distance. Red color is travel much distance than other colors, no, right? Why? Because it has longer wavelength. Due to this reason, the red color is used to show the danger symbols. The red color lights are used in traffic signals. Approximately, for example, here the traffic signal, a red color light, and remaining colors we use it. Okay, the red color light can approximately travels 3 kilometers, then other colors or travel less than 3 kilometers. For example, blue color is travel only 1 kilometer. Okay, then yellow color is travel a little bit more than it, but highest distance the red color can able to travel. Why? Because less scattering takes place, so it travel much distance. So that's why in the red color can use it to danger symbol. For example, if in a traffic signal red color is on, then the person from approximately behind the 3 kilometers or 2 kilometers also he can able to see the red color and he slow down his vehicle. Alright, due to that reason he will use this in traffic signals. Right, got it? And sir, okay, then on earth it has atmosphere, then when we are seeing the sky from the earth, we can see a blue in color and white in color, red in color, we notice it that. Right, same. Then if I observe the sky from the moon, how it is appears, right? Now I am on the moon, right? We all are on the moon, right? From here we are observing the sky. How it is appears? If we observe from the moon, the sky is appears in dark. It appears in dark. Why, sir? Why? Because there is no atmosphere, there is no scattering can takes place. So that's why the sky, when we observing from the moon, it totally appears in dark in color. Due to what is the reason? Due to there is no scattering. Got it? Right? These are the few applications of scattering light. Okay, the scattering and applications of scattering of light is very, very important concept. Right? With this class, our one more chapter is also completed, that is human eye and colorful world. Right? Still you have any doubts, ask me in the chat box. Right? Thank you for everyone.